Hello and welcome to Chapter 6, Section 1 of Pre-Calculus. In this section, we're going to look at what's called the law of sines. And let me back up here one of these. Think back to another math class. You might have seen these before, SAS, ASA, SSS. Do you remember what those are? Remember, the A's and the S's stood for angles and sides of triangles. And like this first one would say that if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, like here I have these, I've marked this side congruent to this side up here with 2 marks is congruent to this one, and the angle in between. If we have at least that much, we know everything else is congruent. I know this angle up here will be congruent to this one. This one down on the right will be congruent to this one, and the third side of this triangle will also be congruent to the third side of that. And that's also true for two angles and the side in between, or if all 3 sides of one triangle are congruent to another. So these are the minimum requirements to show that 2 triangles are congruent. Here in this class, we're going to take a deeper dive than you ever saw in geometry. So here we're going to use the law of sines to solve oblique triangles in the AAS or ASA form. And the next one, we'll use the law of sines for side-side angle. You know, that's not one of our theorems here because there are 2 cases to that one. And in day 3, we'll look at area of oblique triangles. There's a real nifty formula for finding the area of triangles that you have not seen before because it's based on the law of sines. So let's read what the book says here. To solve an oblique triangle, we need to know the measure of at least one side and any 2 other measures, 2 other sides, 2 angles, or 1 angle and another side. So we have 4 cases: angle, angle, side, angle, 2 sides and an angle opposite one of them, side, side, angle. 3 sides, side, 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 and 2 sides and their included angle, SAS. The first 2 cases, 1 and 2, we will solve those with the law of sines. For numbers 3 and 4, in the next section, we will look at the law of cosines. Right. So here, in all its glory, is the law of sines. It's not difficult. It's easy to memorize. What we have here is side A divided by the sine of angle A is exactly equal to B divided by the sine of angle B, and that is exactly equal to C divided by the sine of C. So if we set this up, we can cross multiply to find missing pieces. The key here is we're going to need one of these fractions, both numerator and denominator, to find other components. And we see down here in some of these pictures, this works for acute or obtuse triangles. Remember, we are no longer now in the land of right triangles. 6.1, the law of sines, this is used to solve any triangle, not just right triangles. All right, let's take it for a test drive, see how it works. In example 1, we are given angle C is 102 degrees, angle B is 29 degrees, and side B is 28 feet long. They want us to find all other remaining angles and sides. And in this case, I go for the low-hanging fruit first. Notice we've got 2 of the angles, 102 and 29. That means finding angle A will be pretty simple. Angle A is going to be 180, the total amount of degrees in a triangle, and we're going to subtract the other 2 that we already have, minus 102 and minus 29. If we punch that into our calculator, we're going to find the missing angle is 49 degrees. So I'm going to write that in here on the picture, 49 degrees for angle A. All right, let's set up the law of sines. So the first one is A over sine of A. Here's side A. We don't know what it is, so that's just A. But we know angle A is 49 degrees, so that's going to be the sine of 49. And that is exactly equal to B over sine of B. Well, we know what B is. B is 28, and then angle B is 29, so this will be the sine of 29. And then that is exactly equal to C over the sine of C. C we do not know, but angle C is 102, so this is going to be the sine of 102 degrees. Okay. Now, because this is a big proportion, with all those equal signs in between, we can just find missing pieces by cross-multiplying. So what I'm going to do first, notice here the fraction in the middle, we have both numerator and denominator. That's key. So what I'm going to do is sort of block these off together. And now we're going to cross-multiply. The only thing we don't know up here is side A. So if we cross-multiply, if I multiply this way, we're going to have A times the sine of 29 is exactly equal to the other diagonal, 28 times the sine of 49. Sine of 49. And now to get A alone, we're going to divide by sine 29. So A is equal to 28 times the sine of 49 degrees, all of that divided by the sine of 29. So punch that into your calculator. For the numerator, I would hit 49, take the sine of that, times by 28 equals, divide by 29 sine hit equals. Of course, we're going to make sure our calculator's in the right mode. If you do everything right, A is going to be about 43.5. 43.5 for side A. If I wanted to, I could take this A out of there and replace that with 43.5. Now, look back up here to my proportion. I'm going to take this box. We've solved for A. Now I'm going to slide it over here. And we can cross-multiply here to solve for side C. So if we work our magic over here, we're going to have C times the sine of 29. Ooh, and I forgot. Back. I didn't give you the answer to that last one. Oh, yeah, I did 43.5. Or 43 point, that should be 0.6. What did I think? I said 6. There we go. Okay, now back to that. Again, we're just cross-multiplying here. So C times the sine of 29 is exactly equal to the other diagonal, 28, times the sine of 102 degrees. And to get C by itself, we're going to divide by the sine of 29. All right, and we punch that in the calculator, beep, 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 and we get about a 56.5. And I should have put units on there. That would be feet, because they did tell us that the sides are measured in feet. So there we go. We've found all missing components. Now, example 2 here, it's sort of the same song and dance, but we're not solving the whole triangle. We're just looking for one piece that's missing. So in the setup to this, they say a pole is tilting toward the sun at an 8-degree angle from vertical. I'm going to highlight that. That sounds pretty important. 8-degree angle from vertical. It casts a 22-foot shadow. The angle of elevation from the tip of the shadow to the top of the pole is 43 degrees. How tall is the pole? So we only got to find the height of the pole. And, here's our book picture. I'm going to redraw it. Here's the slanted telephone. Whoa, that's supposed to be a marker. There we go. Here's our slanted telephone pole. And then here's the ground. And then this is the line looking at the top of the pole. And they told us it is a 43-degree angle of elevation. So this is 43. And they're calling this, I think, angle A. Angle B is right here. Now, they told us it's an 8-degree angle from vertical. So vertical would be straight up and down, and we've gone 8 degrees this way. Well, this would have been 90 degrees, but we're going to add 8 degrees to it, so that's going to be 98 degrees. 98. Up here, they're calling this angle C, and the bottom here, this side C, is 22 feet. Now they're asking us to solve for side A. Remember, side A is across from angle A, and that's going to represent the height of this pole in our picture. So let's see here. If we're going to set up our proportion, we don't have to set up the whole thing. Well, first let's find that missing angle. We've got 98 degrees. We've got 45 degrees. So angle C is going to equal 180 minus 98 minus 43. Angle C is 39 degrees. 39. So now when we're setting up our proportion, we need one angle in one side, complete. So here's the side we have, 22, and the angle across from it is 39, so that's going to be one of our fractions, 22 over the sine of 39. And that's going to be equal to the fraction that we have, the side that we want to find. So we want to find side A, and we have the angle across from it, 43. So that's just going to equal A over the sine of 43. And I think I can get my picture out of the way now. And now it's just cross multiplying. A times the sine of 39 is equal to 22 times the sine of 43. And then to get A by itself, we're just going to divide by that sine of 39. So A is 22 times the sine of 43 degrees. And that is all divided by the sine of 39. And we punch that in the calculator. We're going to get approximately 23.8 feet. 23.8 feet. Because again, they were asking us how tall is the pole. 23.8 feet long. All right, here's a couple for you to try. Very similar to the ones we did, just like examples 1 and 2. So it's a good time to pause the video and try these problems, and then get your answers and fire the video up and see if you got them right. All right, so here in this first one, we are missing angle C. If we do 180 minus 30 minus 45, that leaves 105 degrees up here. So angle C is 105. And this, we're solving everything. So let's set up our proportion. Side A over the sine of angle A is equal to side B over the sine of angle B. And that is exactly equal to C over the sine of 105. Okay, again, we need one of these fractions complete, and we've got that right here. So we can cross multiply the red and blue fractions that I have here. Now, if you haven't noticed, to solve and get this B by itself, B is going to equal the other two multiplied, the 32 and the sine of 45. And then the other side would be B times sine of 30, so we're going to divide by that sine of 30 that is across from B. And if you did everything right, that is going to be approximately about 45.25. 45.25, and our units, they are given in the picture here, centimeters. So now if I want to, I can take this B out, and I can replace it with that 45.25. 45.25. Now what I could do to find missing side C, I could slide this box over here and cross multiply with the value we just found, although it might be better to always use the given stuff that we started with. So what I'm going to do is cross multiply C times the sine of 30 is equal to 32 times the sine of 105. Sine 105. And of course, to get C alone, we're going to divide by the sine of 30. Sine of 30. And that turns out to be 61.82. Approximately 61.82, and that is centimeters for that problem. All right, so the triangle's been solved. We found the missing angle first and a couple of missing sides with the law of sines. Now the applied problem, very similar to the tilted telephone pole. Now it's a tilted tree. Find the height of the tree. So let's see, let's just kind of do this one from the picture. We're going to need this angle up at the top. We've got the 23, and we've got the 96. If we subtract those from 180, that angle is 61 degrees. And now we've got, let me switch to red ink, we've got a side, and we've got the angle across from that side. So that's our key fraction here. We're going to have our 30 meters divided by the sine of 61, sine 61. And now the side we want is this side. They're calling it H, and that is across from the 23-degree angle. So that will be our unknown H over the sine of 23. Cross multiply, 30 times sine 23 equals, divide that by the sine of 31. You get the tree is approximately 13.4 meters. And there we go. Found that tree. Okay, this will be our last example in this video, and we're just starting to look at the side-side angle case. Now here it says single solution. When we're dealing with this ambiguous case, this is why there's not a side-side angle theorem in geometry, because there's not just one possible other triangle, there could be two. Now here's how the book introduces it. Consider a triangle in which A and B, the sides are given, and angle A is given, and the height will be B times sine of A. So here we're trying to set up these triangles, and they're saying, okay, if side A is less than the height, there will be no triangle, because this side cannot come down and connect. If A and H are exactly equal, there's going to be one solution triangle. If A is greater than or equal to B, there's going to be one solution triangle. If H is less than A, which is less than B, there's going to be two solutions, and those are all for acute angle A. If A is not acute, if it's obtuse, and A is less than or equal to B, there will be no solutions. If A is greater than B and A is obtuse, there will be only one solution. So this is a lot to memorize and work out just to start a problem. My thinking is you should always assume there's going to be two possible triangles. It's easy to check if there's two possible triangles, and then we can just get that right out of the way. So in this one, they kind of spoil the surprise. There is going to be only one solution, but I can still show you how to check to see if there's going to be another one. Okay. So now notice on this one, it's side-side angle. So we've got one angle, and we've got two sides. So there's no way to find the other two missing angles right off the bat, but we can set up our proportion. So let me go to the picture here. We've got a side, and we've got the angle across from it. So that's the first one I'm going to set up. I've got A divided by the sine of angle A, 22 over the sine of 42. Now if we look at our other given information, the only other thing we got is this side B, and we don't know the angle across from it. But let's set up a proportion. So that's going to equal 12 over the sine of angle B. So here they're forcing us to find angle B first. As soon as we find angle B, we will check for another possible triangle. And let me do it like this. I'm going to draw another triangle just like this one below. And the given stuff will be the same. So this angle down here is going to be 42 degrees. This side is 12. This side is 22. And what we're doing right now is going after this angle B. So let's cross multiply and solve here. We're going to have 22 times the sine of angle B is equal to 12 times the sine of 42. There we go. And we're going to divide both sides by 22. Or no, divide by 22. So now over here we've got a 22, and that's equal to the sine of B. Now if we're looking for an angle, remember this is where we use the inverse functions. In this case we're going to use sine inverse. So if you punch in on your calculator, 12 times the sine of 42 equals, divide that by 22 equals, you'll have some decimal, and you're going to do sine inverse. And that is going to tell us that angle B is about 21.4. 21.4 degrees. So I'm going to come to the given picture, and I'm going to write angle B is 21.4. Now here is where we're going to check for our second possible triangle. And the check is very simple. I'm going to take 180 minus this angle B, 21.4. And if I subtract that, I get 116.5. or 6, 116.6. So I'm going to do 180 minus this angle B. That's this other angle B. So I'm going to write in there 116.6. 0.6. There we go. Now look at this blue triangle I've drawn. The angle they gave us was 42, and we're saying this over here is going to be 116.6. Whoa, 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 whoa. Back. My bad. When I subtracted 180 minus 21.4, I was looking at the wrong part of my notes. 180 minus 21.4, that's 168.4. So this angle here is 168.4. Now think about that. There's 180 degrees in a triangle. Angle A is 42. Angle B is 168. If I add those together, I'm greater than 200. So there is no second triangle. This is just a single solution case. So we can now totally forget about a second triangle. It's not happening. We can go back and finish solving the triangle we started, and we're done with it. Okay, so now we've got angle A is 42. We've got angle B is 21.4. We can find angle C by subtraction. Angle C is going to be 180 minus 42 minus 21.4, and that tells us angle C is going to be 116.59. 116.6. Yeah, because I rounded that to a 4. That'll round to a 6. And now all we got left to find is side C. And we've got our law of sines. So I'm going to go back to that red one. I'm going to leave that there, the 22 over the sine of 42. And now I'm going to set that equal to C over the sine of 116.6. And again, we're going to cross multiply and get C by itself. So C is going to equal the other diagonal, 22 times the sine of 116.6. And we're going to divide that by what was across from C, the sine of 42. And if we punch that carefully into our calculator, we're going to get side C is approximately 29.4. And in this case, our units were inches. So that's a side length. We've got that in inches. All right, triangle was solved. There was only one solution case. So again, just to recap that, they're going to force you to solve for an angle. They gave us side A, and we had angle A. So that was our starting fraction. They gave us side B, and that was going to force us to find angle B. As soon as we find this angle B, subtract it from 180, and that might be angle B in the other possible triangle. But again, in this case, it didn't work. There weren't enough degrees to go around, or there were too many degrees in our triangle. It was above 200, so there was no triangle. All right, here's your practice one. Now notice here I've got two triangles. And remember, if there's two solutions, they're going to have the same given info. So when I'm marking here, angle A is 31. This angle A is 31. So is the other angle A, 31. Side A is 12. Side A is 12. Side B is 5 inches. 5 and 5. So now that we've got these set up, I will encourage you to pause the video, try to find the missing angles and sides, and check for that second possible triangle. Whoa. Go. All right. So they gave us the side of 12 and the angle across from it. That's where we begin. 12 over the sine of 31 degrees. That is exactly equal to, the only other info we have is this 5, and that will be across from angle B. So we're going to have 5 over the sine of angle B. If you cross multiplied and solve correctly, remember you're going to do 5 times the sine of 31 equals, divided by 12 equals, and then you're going to sine inverse. You should have got angle B to be about 12.4. 12.4. So now I'm going to go back up to my picture. And in my first triangle, I'm going to switch to blue ink. I'm going to put in 12.4 for angle B. So this is 12.4. And now this is where I check the other triangle. If there is another triangle out there, its angle B is going to be 180 minus 12.4. 180 minus 12.4, that is 167.6. So if I write this angle as 167.6, 0.6, that's already more than 190 degrees. If I add this angle A and B together, it's over 190, so that's not a triangle. We can cross it out. There is no second solution. So now we can just go back and finish off the triangle that we started over here. So we've got angle A is 31, angle B is 12.4. If we subtract, we'll get 136.6. 136.6 for angle C. And then if you set up C over the sine of 136.6, that's equal to 12 over the sine of 31. Cross multiply and solve there, and you're going to get side C is about 16. C is approximately 16. And now let me point this out. Now this will really pay off good gains in the next section. But remember, a triangle has to make sense. The biggest angle is across from the biggest side. The smallest angle is across from the smallest side. So in this triangle, our biggest side is 16, and it is across from the biggest angle, 136. The smallest angle is 12.4, and that is across from the smallest side. So that's just an easy check for the reasonableness of a triangle. And again, that's really going to help us in section 6.2. And I believe that's the end of the video. Yeah, so the WebAssign, the homework's on WebAssign. It's going to be these even ones down here. These odd ones we will do together in class. The ones we're going to do in class will round to 2 places. Make sure you watch on WebAssign. They will tell you how much to round to in the directions. And always use the given sides and angles as much as possible. When you find a missing part, you might round it off a little bit. If you use that in a later computation, more error will grow because you're using stuff that was rounded off. So I will see you in class. We will do some odd problems and look forward to the next video.